This is February, March 2024, paper 1-2. Let's start with this paper. So question number 1 suggests physical quantity with the base unit. So we have to figure this out. Okay, so current is amperes, so this is correct. Force is not a base quantity, plus it goes with MA, which is a derived quantity as kgms minus 2. Mass is a base quantity, but the unit is not grams but kilograms, so this is incorrect. Temperature is one of the base quantities, but that has to be in Kelvin, which is the thermodynamic temperature. It could have been degree Fahrenheit as well, but that would be incorrect. So the correct answer that has the correct base quantity with the correct unit, SI unit, is option A. Moving on to question number 2, this is a very basic O-levels sort of question. It says that a certain free body diagram is given to you. One force is 1200, the other 1600. What's the magnitude of acceleration? So we're simply going to use the F equals to MA, the pulling force minus the stopping force. So this could be 1200 minus 1600 equals to the mass is given as 850 into the acceleration. So the acceleration is going to come out as negative 0.47 meters per second square. So the negative suggests that this is deceleration because we can obviously see that the backward force is greater than the forward force, which means that it is going to be decelerating, but with a magnitude of 0.47. So don't confuse acceleration being always positive. Acceleration can also be negative. We just give this a special name sometimes, that is the deceleration. So acceleration can be positive, it can be negative. Question number 3, he wants you to find out the homogeneity of this equation, and he tells you what everything is. So m is the mass, which means that this will be kg. K is the spring constant, which is in Newton per meters, and t is a time period, so this is going to be in seconds, right? So we have to try all the options and see which one of them will be giving me the correct answer. Now notice that if you deal with K in any formula, you can see that this left hand side should be in seconds, right? And on the right hand side we can see that 2 pi is a constant, so no need to think about it. We have K divided by mass, and for newtons we have F equals to MA. From F equals to MA we have kg ms minus 2 divided by meters gives me kg s minus 2. So this is the unit of my spring constant. Now when I replace this over here as kg s minus 2 divided by m, mass, then mass base unit is kg again. So kg gets cancelled with kg. So I'm left with in t equals to s minus 2, right, in this option A. If I try option B, I can see that this is just taking a reciprocal of that bracket, and I will end up with s square no matter what I try to do. Okay, so just solving option A has given us an insight of option B, so no need to solve it again. Let's go towards option C and D, and let's see what's going to happen over here. So we can see that the under root takes care of K and M, and then M over K. So just solving one part or one equation of one option will give us the insight of the second option. Again, we don't have to think about the constant value, we just have to think about the values or the variables that are given to us already. So K was, as opposed or as found before, is kgs minus 2. So let's solve this one. So this is kg s minus 2 divided by the mass, which is kg, right? Now kg gets cancelled with kg, we are left with s minus 2, and this is being inside the under root. So under root of 1 over s square, or this s minus 2 will be taken of course in the numerator, in the denominator. So we're left with 1 over s. So time is not 1 over s, 1 over s is actually frequency, which is hertz. So this should have been seconds only. So I suspect it should be option D. But for the sake of understanding and for the sake of removing any chances of error, let's solve this. So m is simply kg divided by kg s minus 2. Kg gets cancelled with kg, and s minus 2 goes over there, so this becomes s square. And if you don't forget the under root, we realize that this is still this equation. Now taking the under root of any square power gives us the variable as it is. So time period equals to seconds, so this is going to be option D. That is how you check for homogeneity of an equation. Question number 4 suggests an object of mass initially at rest at point P. The object moves away from point P with a uniform acceleration. It could be in any direction. Which statement describes the resultant force acting on the... Now, for the resultant force and acceleration, we use the equation F equals to ma. If the mass is constant, then force and acceleration will be in the same direction and will be proportional to each other. It says it increases uniformly. No, it does not, because if the acceleration is uniform, if it's a constant acceleration, then the force will also be constant, or the resultant force will also be constant. It is constant but not zero. This seems like a plausible answer. It is proportional to the displacement. No, it's not. It is actually proportional to the acceleration or the force. It is zero. No, it's not zero, because the resultant force has to exist in order for the object to accelerate. Now, a simple example would look something like this. So this is 100 newtons of force, and let's say it is being opposed by 50 newtons of force, and that would be 100 minus 50 equals to ma. So we have a resultant force of 50 newtons producing an acceleration in mass m. So it can't be zero, right? So option B seems to be the best answer in this given circumstances. Question number 5 says we have a component launched at 25 degrees and the horizontal component is 13 meters per second. First, let's try to draw this, what it actually looks like. So this is the vertical component and this is the horizontal axis. We have something launched at this point with an angle of 25 degrees, and if I want to draw the components along the x-axis, that is going to be 13 meters per second. And the vertical component is what is being asked from us. We don't know that. Now, first we need to find out the actual value of v, or the velocity. We're going to use the horizontal component. So from the horizontal component, we can see that for the horizontal component, we have an equation that 13, whatever the answer may be, right, is equal to the v cos of 25. This is the cos component, right? Now, when you solve for v, v comes out as 14.34 meters per second. So this is 14.34, right? Now we can take the next step. So now we can use this to find out the vertical component. So the vertical component goes something like this. So this is supposed to be v sine of 25, which is this one, right? So this is v sine of 25. So when you find 14.34 into sine of 25, you realize that your answer is going to be 6.06 meters per second, which is option B as 6.1. Of course, I've rearranged the paper. You can see that there is a lot of space between the questions because I want to make sure that the working can be shown to you in these questions. So now we have question number 6. It says that the ball released from position x at time t equals to 0, and at time 1 it bounces inelastically, reaching a top speed, or sorry, the top of the first bounce at 1.5, so on and so. It says what's the total displacement of the ball from the original position of x at 1.5. Now, collectively, if you just want to get it over with, if you would just want to solve this, what you would have done is simply found out the total displacement from the starting position, because this is the starting position, right? If you want to visualize it, then you'll have to bear with me. Consider that this is the bench where the ball was released from, right? And it is at a certain height, and this is our ground. So the ball was released from this height. It falls down and collides with the surface or with the base, and then rebounds and then achieves this certain height and then starts falling down again, probably, right? But the only motion given in the graph is up to this point, that it reaches the highest point at 1.5. So what happens after that? So we're going to limit ourselves up to this location. The thing that he's asking us is the displacement from the starting point. So if this is my starting point, this is my starting point, and this level is my ending point, then the displacement will be from the starting point till the ending point, right? So this is what I'm supposed to find out. Now the first half, now since this is a velocity time graph, I can understand that the area will give me the displacement, the area under the graph, right? So the first half, the green half, gives me the displacement covered while falling downwards. And the orange half gives me when it was going to go back up again, right? So if I take the difference of both areas or displacements, I will find out this difference. I will find out this distance. This is what he's asking in the question, right? Position from x. Now this is my x. This is where it started from. So simply put, I'm just going to take the difference of both areas, right? So this is going to be 1 over 2 into base. So the base of this part is 1. The height of this part is 10 minus the triangle of the orange. or the area of the orange triangle, right? So this will be 1 over 2 into the base is 0.5 from 1 to 1.5, and the height is 5. Notice that I've already included a negative sign over here in the formula because I understand that they're going to be different. They're going to be subtracted, so no need to add minus over here again. So when you do that, your answer comes out as 3.75 meters, which means that this distance, or this displacement, sorry, is actually 3.75, right? So this will be my answer as option B. Question number 7 suggests, what is the definition of acceleration? Now, acceleration is equal to rate of change of velocity. Now, it says change of velocity per unit time, right? This seems like a plausible answer. Let's keep that in mind. Rate of change of speed, no, it should be velocity, right? So this is an incorrect definition. Rate of change of velocity per unit time. Now, this seems like a good answer, but it is there to confuse you. How is it confusing us? You see, the word rate in physics already means that some quantity is going to be divided with time. First, you write down rate, and then you're saying per unit time. So it's something like this, that something is being divided by time, and then again divided by time. So it is going to become something divided by t squared. So again, it is incorrect, right? So be careful about these words. And option D, resultant force per unit mass. So this F divided by m equals to A. This is from the Newton's second law. This looks like a plausible answer, but this does not define acceleration. This is not for the definition of acceleration, right? So the definition is the rate of change of velocity. It has to have a velocity, it has to have a time. So option A seems to be the right answer, and all three of them are incorrect. Now, question number 8, he says, now this is an interesting question. He says, there are two balls moving towards each other. A few key points before starting this question, which will help you in the future as well. First, notice that they are equal masses. Now, when the objects are of equal masses and they are colliding perfectly elastically with each other, then only then their velocities exchange. The velocities will get exchanged, as you see in an example of a snooker game, right? Now, since we still have to solve this, let's move on to the question. It says straight line towards each other, and the ball P has this velocity, Q has this one to the left, and so on and so forth. He says they're colliding perfectly elastically. Another thing that we pick up from perfectly elastic is that even if the masses were not given to us, even if the information of mass was not given to us, we still can use the relative speed rule. The relative speed rule. If you're not familiar with this, please go watch the video of momentum. I've solved approximately 2 to 3 questions explaining how to use this rule for a perfectly elastic system. Now, this perfectly elastic statement enables me to use the relative speed rule. And what does that, and how to use that, right? So since they are both moving towards each other, in the before case, I will simply add their velocities. So this will be 1.3 plus 0.5, giving me an answer of 1.8 meters per second. The relative speed is 1.8. Now, if they are perfectly elastic, then their after collision should also be producing the same relative speed answer. Now, let's try all the options, right? First and foremost, which option should be cancelled? Option B will be cancelled. Why? Because when they are joined together or when they are lumped together, they cannot remain a perfectly elastic collision. That is one of the tricks, right? So if they're joined together, they are not perfectly elastic. No questions asked. Let's try option A. The relative speed should be the same as before. So now if they're moving in the same direction as shown by the arrows, I'll have to subtract them. If they're moving opposite to each other, then I'll have to add them. This is the relative speed rule. Please go watch the video. Now, if they're moving in the same direction, I'll subtract the value. So this will be 0.58 minus 0.22. I understand that mathematically I need to get 1.8, and if I'm already subtracting these two values, my answer will be less than 1.8. So I don't need to solve this, but I'm solving this for you guys. So this is wrong as well. I should get 1.8. Option C, they're opposite to one another, so they will be added together. So this will be 0.99 plus 0.19. Mental math tells me that this answer, even added together, will still not be good enough to make 1.8 after addition. So that is what we get, 1.18 meters per second. This is also incorrect. Let's move to option D. First, we try the relative speed rule. We see that they're opposite to each other. They're moving opposite. So we'll be adding the velocities, which will be 0.5 plus 1.3, which is 1.8 meters per second. According to the relative speed rule, this is the correct answer. Now, if you did not want to use this, a much shorter way, a much quicker way was to visualize that if the masses were equal and they are colliding perfectly elastically, their velocities will get exchanged. Now notice what's happening. P was incoming with 1.3. Now P is going away with 0.5. This was the velocity of Q before. And P was incoming with 1.3. Now this velocity is possessed by Q. So you can see that the velocities are exchanged. So this is a special case of momentum. So I would have saved time even not employing or not using relative speed rule. Okay. Question number 9 suggests basketball. Now this is a simple equation of motion question. We have an initial speed u, we have the displacement, we don't need the time, we just want to find out the speed before hitting the ground. So I can suspect that the equation that we want to use is v square equals to u square plus 2as. Now this is what I want to find out. So the initial speed is 2.4 whole square plus 2 into 9.81 into s, which is 0.9. When you solve this, you get v equals to, after of course taking the under root over there, for the whole system, you get 4.839 meters per second, which is 4.8, which is option B. Now, you might get confused about what to do with the value of gravity. You see, if the ball is already moving downwards, if it is already possessing a speed of 2.4 in the downwards direction, the gravity is also in the downwards direction. If it is in the downward direction, it is helping this velocity, right? So if they are in the same direction, if you were to, let's say, if you were supposed to take this value as vertically downwards as negative, right, they're going to be in the same direction. So they're going to help each other. So this 9.81 should be causing an acceleration for the whole system. So answers should be greater than that, right? So this is how you deal with the situation. So this will be 4.8, right? Okay, question number 10. A ball falls through a liquid at a constant speed. Now, constant, always underline this word constant speed. This is always the hint for the questions of motion. It is acted upon by three forces, okay, upthrust, drag, and weight. So we have an object that has an upthrust, which will be up. We have drag, let's draw that later, so that we have weight. Now, if this is falling through liquid, the drag opposes the motion, which means that if the object is moving down, the drag will be upwards. The same thing happens with the parachutist. The parachute is coming down, the drag is going to be upwards, right? If they were moving up, the drag will be downwards. Now, which statement? The liquid has uniform density. We're good enough. Now we know that the upthrust has a formula of rho g v, v being the volume of the liquid displaced. Now it says uniform density, so we don't have to think about this. We don't have to think about g. And of course, the object's volume, which is inside the liquid, will be displaced by the liquid itself, right? So moving on to the options, let's try the options. The drag force increases. No, it does not. The actual answer is that drag actually depends on speed and surface area. Now, since it is moving at a constant speed, the drag is not changing or will not change. So option A is incorrect. The drag force is equal to the sum of upthrust and weight. Now, if you were to do this, since it is moving at a constant speed, that means the downward forces are equal to the upward forces, since the acceleration is equal to 0. So according to F equals to ma, this side becomes 0. So the resultant force would be W minus upthrust minus drag equal to 0. Let's take this over there. So this becomes W equals to upthrust plus drag. Right? So they are equal to this equation. So he says drag is equal to the sum of no. So this is fundamentally wrong in terms of Newton's second law. He says that the upthrust is constant with increasing depth. Yes, this seems like a plausible answer. The upthrust does not change because it depends on the volume. The volume is constant, so it does not matter. The weight is greater. No, the weight can't be greater. If the weight was greater than the sum of upthrust plus drag, then it cannot move at a constant speed. It would be moving with some acceleration. He would have mentioned that the speed is still increasing, right? So it can't be greater. So this is again a violation of Newton's second law. So the best answer in this situation is option C. Question number 11 is actually a problem, or is actually a test of units. It says that each cube is 1 kg with size 5 by 5 by 5. He says they're stacked together to form a large cube of this side. So what is the weight of the large cube? No problem. So first find out that the small cube has a volume of 5 into 5 into 5. So this becomes 125 centimeter cube, right? The next thing we have is the large cube having sides of 2 by 2 by 2. Please notice this is in meters, right? So this will be 2 meters, 2 meters, and 2 meters. So this comes out as 2 into 2 into 2 as 8 meter cube. This is where you're going to get confused, right? Please make sure that you use the units correctly, right? So we want to find out how many boxes are there, how many boxes are going to squeeze into this large cube if they were stacked with these small boxes, right? If these small boxes were stacked together, this is what it's supposed to look like. Okay. Now, how to count the number of boxes? Simply divide this volume with this volume, right? So we have 8 meter cube divided by 125 centimeter cube, but to convert centimeter cube into meter cube, you have to divide this with 100 cube, right? So this goes in the numerator, and when you solve this, you find out that the total number of boxes that you get is going to be 64,000. So 64,000 boxes, if stacked together, is going to look something like this. Now it is just a matter of using W equals to mg. So each box has a mass of 1 kg. How many boxes? We have 64,000. What is the value of G? 9.81. When you do this, you get 627 into 10 raised to the power 6 newtons, right? So this is going to be option C. Moving on to question number 12. Again, I've moved the diagram to the left because we want to see, we want to use the space for the equation. He says that the borehole of this depth, this so and so, the pressure due to the liquids at the top of the borehole is 17.5. So the total pressure by the oil and the water at this point at the base is 17.5 megapascals, right? The density of the oil and the water is given. He says, what's the value of depth X? No issues at all. Very simple question, very straightforward. So combining the pressure of the oil plus pressure of the water, they should be equal to 17.5 megapascals. Now let's find out the equation for all of them. The liquid pressure equation goes like rho GH, right? So oil is 830, G is 9.81. Now for oil, the depth is X, so this is X. Plus for water, this is 1000 into 9.81 into this height would be 2000 minus X. The total minus the length of the column of X, right? So we get 2000 minus X equals to 17.5 megapascals, which would have to convert into 10 raised to the power 6. Now here I present to you a problem. The problem is that solving this equation in terms of algebra is going to cause some trouble. It's going to cause some problem, right? First you have to multiply this bracket, then you have to deal with the negative sign, then you have to deal with X, and then you have to deal with power of 6. So I advise you to make the function on the calculator. Make the function on the calculator and try all the options. I've done this already, and I will cut that video, or cut that part after this MCQ. So you can see how to make the function on the calculator and how to save time. Try all the options and you will see that the answer only gets to option D. I can give you the answers for A, B, and C as well. So my point is that if you try option A, let's say you put 907 over here and 907 over here, you should get 17.5, right? So try all the options, then try 1000, then try 1090, then try 1270. So when you try all of these options, you get that the total pressure in this case will be 18.1 megapascals. In this case, it was 17.95 megapascals. In this case, it was 17.8 megapascals, and 1270 gave me 17.5 megapascal. So since this answer only gives me this answer or matches with it, so I will choose option D to save time, right? Again, I will cut the calculator video, how to do that over here. Then you can try this on your own. Okay, so what we can do is make the formula that we've just written down and make sure that we try all the options. Now, the good thing about P1 is that you don't have to perform the algebra. If the options are numerical in nature, you can just try all the options. So we have 830, then we have 9.81, right? And then we have, again, the variable x, whatever that distance may be. Now, I will press the button of calc and see and try all the 4 options and see what answers do I get. So when I try the option number 1, which is 907, I get, by pressing the ENG button, I can convert this into standard form. I get 18.1 megapascals, which is not my answer. It should be 17.5. So I press calc again. I try option number B, which is 1000. I get 17.9. Again, not my answer. So I press calc again. I try option C, which is 1090. And I again get 17.8, which is still not my answer. So then I press calc again to try option number D, which is 1270. I get 17.5 megapascals, which is my answer, right? So by this method, I have avoided performing the algebra or the variable manipulation. So I would recommend, or I would at least do this method to save time. If you're more comfortable attempting the algebra side of the things, then that's completely your choice. So now we have question number 13. Question number 13 proves to be a bit tricky, but we have a diagram for that to understand it. He says that the rod is initially at a horizontal position, hinged at one point, right? And the weight of, and of course, definitely, this is the weight, will cause a moment about pivot P. So if it was left hanging, it would move clockwise, right? Okay, like the door of a freezer. So the rod is rotated vertically and then goes up to 180. So from this point to this point, the rod is being rotated, right? Or it oscillates, let's say. So what diagram represents the moment with theta? Okay, so first of all, let's make the equation. Let's see what the situation looks like. This is what the situation is, right? So the moment would be downwards mg, the weight, multiplied by the distance from the pivot, which is d. Okay, so at this point, the theta is equal to 0 degrees. And at this location, let's assume that the theta is actually equal to 180, right? Okay, so when it comes down, or when it starts moving downwards, let's say this angle is now greater than 0 degrees centigrade, whatever this angle may be, right? So let's consider this to be theta, okay? The mg component is still downwards, but if you draw the components, this is going to come out as mg cos theta, and this comes out as mg sin theta. And this component is responsible for the moment. This is responsible for the moment, right? Moment generated with the distance. This is our distance. From this point to this point, this is our distance. And in the direction or perpendicular to the direction of the distance is actually mg sin theta, right? We can see that sin theta, or the angle, is reducing. So when it eventually comes to this point, the mg is downwards. The distance is also in this direction. There is no angle between the force and the distance. So at this point, the moment becomes 0 at an angle of 90 degrees, right? Over here, it was not 0, but it was decreasing, because at this point, the moment was equal to mg multiplied by d, maximum moment, right? And slowly it decreased to become 0, then started to increase again. But at this point, the moment is going to become anti-clockwise. You see, if it comes to this point and you allow it to move, it would want to fall in this way. So at this point, it is actually anti-clockwise. And from this point, this is actually clockwise. So since both moments are opposite to each other, and this equation actually goes something like this: moment is equal to mg sin theta multiplied by d. So the dependence of m with theta can be found. We can see that it is going to be a sinusoidal function, right? It is dependent on sin theta. So it cannot be a straight line. It can't be this one. It can't be option C. It has to be between B and D. Now, when you make a choice between B and D, you realize that if the positive or the clockwise moment was supposed to be positive, then the anti-clockwise can't be positive. It cannot be like this. It has to have a sign to show that these moments are opposite to one another. So the only graph that follows a sinusoidal function, which is sine graph, or at least a cosine graph, is option D, right? So I hope that we understand where this equation actually comes from. Question number 14 requires a bit of understanding. He says that a door is hinged at this point. We have three forces, and let me remind you, this question has been repeated. It first appeared in October-November 2003, and then it appeared in May-June 2013, paper 1-1. I wasn't able to find other papers. I suspect that it was also repeated in papers after 2013. It is one of the common questions from forces and vectors. He said that the door is hinged, and this is the question. You might have already read the question. The tension T, weight, and the force H on the hinge. Okay, no problem. He says list by the forces increasing, which means that the leftmost force should be small and the rightmost should be the largest force. First, let's draw, or let's try to make sure that we have a vector triangle, or at least let's try to make the equations. You see, there will be a horizontal component of tension like this way and a vertical component of tension like this. Let's say that this is the angle theta, okay? Or let's make this angle as x. This is angle x, and this is angle y, right, for the components. And then we have a component over here of h and a component over here of h. So since the trapdoor is held closed, it means that it is in equilibrium condition, which means the clockwise moments are equal to the anti-clockwise moments, and the vertical and horizontal components are completely equal to each other. So first, let's make sure that what we do about, or what we know about the horizontal components. Horizontal components are due to the tension and due to H. So it will be T cos of X equals to H cos of Y. But does this tell us anything about the values of T and H? Does it give us any information, right? So we can suspect that if you take cos theta over there, we can realize that T is equal to H cos of Y divided by cos of X. The T would be greater than H. But we can say the same thing when we bring cos Y over there about H. We can make the same conclusion. So this equation does not tell me anything, or does not give me the idea which one would be greater, which one would be smaller. So I'll have to reject this. So if you move on towards the vertical components, right? So the vertical components give us some insight in the situation. So in vertically, this is the weight downwards. There is a component of H and there is a component of T. Since all of that is balanced, the downwards component should be equal to the upward component. So this will be T sine of X equals to H sine of Y plus W. Now this equation is going to tell us, or is telling us, that T, when you take sine theta over there, we can see that T is greater than H and W combined, because when you add them together, only then it is equal to a component of T. So from this, we can conclude that T is greater than H and W, but it still does not tell us the relationship between H and W. What should we do with that, right? So T should be the greatest, okay? Now, luckily, what happened with us in our case is that there is only one option in which T is the greatest, and that is option C. But it still does not justify. What if another option had T at the end? Would it be W, H, and T, or should it be H, W, and T? What would be the answer in that case? So to understand that, let's make the vector triangle diagram. You've done this in O levels as well, and you're going to do that in A levels as well. So first draw the weight, which is downwards, then copy all these vectors as they are represented in the diagram. No changes at all to their direction and shapes. So T goes somewhere along this line. So head to tail method suggests T should be like this. Okay, no problem. And then we have H going somewhat like this. So now I can see clearly that T is greater than H and H is greater than W. So this option C seems to be the best answer. Question number 15. What is the definition of force? Problem, and this is second law. Mass and velocity, no, this is momentum, so this is also wrong. Rate of change of momentum, this seems like a plausible answer. Rate of transfer of energy, no. Rate of transfer of energy is actually power. So this is again wrong. So this is the correct answer, as rate of change of momentum divided by time taken. This actually goes towards impulse, right? A boat moves at a constant velocity. Acceleration is 0. Velocity v through the water, drag force, a constant drag force F is acting on the boat. Okay, what is the power developed to move through the water? Now this is actually one of the proofs. So we have a power, work done divided by time, and work done is F into d divided by t. If you isolate this d by t, this becomes a speed, which is again considered as velocity in this case. Now what is this force F? We understand that it is moving at a constant velocity, so talking about v is not the problem. The problem is talking about the force F. He's saying this is a constant drag force. Should this be equal to something else? You see, if it is moving at a constant velocity, it means that the drag on the object should be equal to the force coming from the engine. So this question is actually, or may be asked from you in another context, in which he gives you the force of the engine alone. You see, they're both equal. The force of the engine minus the force of the drag should produce an acceleration. But is it accelerating? It is moving at a constant speed. So this part becomes 0. So when you take drag over there, this becomes that the force of engine is actually equal to the drag. So it does not matter if you look at the force component, or if you look at F from the perspective of the drag, or you look at it from the perspective of the engine, they are both equal. Only then it is moving at a constant velocity, right? So we land at this equation, which is F into V, which is option B. And those who have memorized this formula would immediately realize that this is a very straightforward question. It is a time saver. Question number 17, again back to the basics. He says there is a circular disk, and I can see that there is going to be some torque because we have vectors, we have forces in the opposite sides, right? Anti-parallel to each other with some distance between them. So the red one is 2F r, let's say if this is the distance r, and the purple one would be again a 2FR system, right? All right, if you don't take R, then if this is D, then this will be FD, and FD, the total torque or moment, would be 2FD or 4FR if it is radius, or if it is the diameter. Force to magnitude F is F, so it seems to be equal vertically, and okay, fine. All forces in the same plane of the disk, no other force acting on the disk. This is important. Diameter D. Okay, so we are supposed to look at from perspective of the diameter. The disk is in equilibrium because the resultant force is 0. First of all, the disk is not in equilibrium. So option A and C get cancelled out. The disk is rotating. For a condition of equilibrium, first condition is that there should be no torque. And simply put, there should be no rotation. It shouldn't be rotating. The second condition is there needs to be no resultant force. In terms of F equals to ma, there should be no force. It could be moving at a constant speed. It shouldn't be accelerating, right? So this is not in equilibrium. So this is not in equilibrium because the resultant force is 4. No, not the resultant force, the resultant torque. So torque would be a better answer, right? So this is 2FD. So D is the correct answer. Resultant force would mean that the object itself is moving left, right, up, and down. There are no other forces acting except from these four. So they are going to cause rotation rather than moving in a certain direction. It's not going to move over here, or over here. It is going to keep rotating on its own axis, right? So we need to keep this in mind. All right. Okay. Question number 18 is from projectile motion, and very, very straightforward and easy question. He says the respective energies or kinetic energies are given at these locations. The heights above the ground at 4 points is shown. Air resistance negligible. Good. Thank you. Which difference in kinetic energy is the smallest? You see, at the highest point, the kinetic energy is actually the minimum or the least possible answer. Why? Because we only have the horizontal component, the vertical component becomes 0. So at all other points, the kinetic energy will be greater than the maximum point, right? So if we want to find out the smallest difference, I need to see which height has the smallest difference. So 1.8 could be minus or subtracted 1.5, 1.6, 1.3, and all the heights can be subtracted from each other. There could be many possibilities, right? So I'm going to choose the one or the numbers that are closest to each other. So I suspect 1.5 and 1.6 are closest. So if you draw this level and you draw the level of 1.6, there is a very small gap between them. So a very small gravitational potential energy is going to translate into the smallest change in the kinetic energy, right? So the answer would be option A, as Q compared with S would give me the smallest change in kinetic energy, right? All right. Question number 19, we have the battery of a small tablet computer, initially okay, 10 watts, 2 hours charge battery, 80% efficiency, very straightforward. We have the formula for power equals to energy divided by time. Let's take time over there. To find out energy is equal to power multiplied by time multiplied by the efficiency, because that is what you get effectively at the end of the day. So this is 10 multiplied by 2 multiplied by hours converted into seconds would be 60 multiplied by 60. And then you involve the efficiency, that is 80%, because you're not getting everything that you invested. So 80% of what could have been the best day will be equal to 57,600 joules. So this is 5.8 power 4, which is option C. Question number 20, initially stationary firework explodes. And when it is stationary, this is important, that the initial momentum is 0, right? Splits into 2 fragments that move horizontally in opposite direction. Very easy to visualize. So one of the fragments is moving in this way and one of the fragments is moving in this way after the explosion. So before the explosion, the momentum was 0. So after the collision, it should be 0. So momentum of particle A plus momentum of particle B should be equal to 0. Or you can say momentum of A should be equal to momentum of B, because this is going to be a negative sign, because one of them is moving towards the left side, right? Momentum is a vector quantity, so you need to include the directions. One fragment is m, the other fragment is 2m. So we understand that in order for this to have equal and opposite momentum, if this is velocity v, then this would be v by 2, because then this becomes mv, this becomes 2m multiplied by v by 2, again becoming mv. So yes, this is acceptable, that the left momentum is mv and the right momentum is mv. When you add them together, this becomes 0. So this seems like a plausible answer, and that is how we have assumed the velocities in these situations, right? Okay. He says the total energy of the whole system becomes equal to E. Find out the speed of the fragment, which is m, immediately after the explosion. So you have to write down the kinetic energy equation. So algebraic manipulation is required. So 1 over 2 into m into v square plus the kinetic energy of the second particle, which is 2m into v by 2 whole square, equals to the capital E, the total energy of the system, right? When you simplify this, this comes out as 1 by 2 mv square plus 1 by 4 mv square equals to E. When you add both of these together, because the variables are same, this becomes 3 by 4 mv square equals to E. It's a matter of then algebraic manipulation, because we want to find V. So this becomes V square is equal to 4E divided by 3m. Then you take the under root, that becomes V equals to under root 4E divided by 3m, which is going to be option D, right? This is going to take some time. There is no shortcut for this. Question number 21. He says a spring is a fixed point, okay, F, and elastic potential energy, which is half kx squared. Spring constant K. Spring obeys Hooke's law, no problem. Which relationship is correct for the spring? So we can see that elastic potential energy is actually dependent on the square of the spring, right? Now, this could be a relationship as well. This is a plausible answer, but K is a constant. It does not change. So the dependence is actually not with K, but with the changing X, because we apply a force F, and that causes an extension or a change of length. So this should be the plausible answer. All right. Now, Now we can argue that there is another formula for elastic potential energy, which is half Fx. Now, I will remind you that when you use Hooke's law, which is F equals to kx, replace it over here, this again becomes half kx squared, right? And the potential energy depends on the displacement away from the mean position. You see, this is the preferred equation for elastic potential energy. So this is going to be option D. The rest of them are, this is good, this is better, but this is the best one. So we have to choose the best answer. The best one is this. And if the graph was given, for example, with the extension and elastic potential energy, this would go something like this, right? With an equation of y proportional to x squared, the parabola. Question number 22, we have a force extension graph produced by a metal wire. What must describe limit proportionality? So there is a force and the extension. What would be describing what? Let's see. A point where the wire breaks, that is the ultimate tensile strength. The point beyond which Hooke's law is not obeyed looks like a plausible answer, because at that point or after that point, the line curves and stops being proportional, stops being a straight line. See, over here we can follow F equals to kx. Because it's a straight line, it is the proportionality. And after this, it becomes a curved line, so this does not equal to kx any longer. That's why we call that as limit of proportionality. Beyond the concurrent, no, that is something else. The point which deformed plastically, no. So this is option B. Now question number 23 requires a bit of an understanding. He says spring constants are given, weight of 80 newtons is given. He says what's the extension? You see, 80 newtons, this is actually a series configuration of the springs. And to visualize, you see, this 80 newtons is being lifted or is being experienced by this spring and this spring collectively, right? So 80 newton has to be lifted by this spring and is, or we can say it is being felt, it is being supported by both springs individually or independently. So in order for us to find out the extensions individually, we can just use Hooke's law, which is F equals to kx. So 80 newtons of force experienced by 6 newton at x, x comes out as 13.33 centimeters. This is the first extension. The second one, F equals to kx, would be again 80 newtons, spring constant 4, into extension is what we want to find out, x comes out as 20. When you add them together, this comes out as 20 plus 13.3, which is going to be 33 centimeters. If you were to solve this by the series method of springs, then you'll have to combine them together by using the formula 1 over 6 plus 1 over 4 equals to 1 over the total spring constant. The spring constant in this method comes out as 12 by 5. I'm taking the fraction because I want to find the correct, accurate answer, although I discourage taking fractions. So then we have F equals to kt into x, because we found out the total spring constant because of both of them. So this is going to be 80 equals to 12 by 5 into extension. Now when you solve this by taking 5 over there, dividing by 12, your x again comes out as 33.33 centimeters, which is option D. So whatever method suits you, whatever you choose to do is your choice. 24, he says, okay, so the frequencies are given. Speed is given, which is 1500 meters per second. It says what's the range or the approximate range. No problem. We have to use V equals to F lambda twice. So V equals to F lambda. So this is 1500 equals to F is 10 and this is lambda 1. This will be 1500 where the F is 40 and lambda 2. So this lambda 1 comes out as 150 meters and this lambda 2 comes out as 37.5 meters. So I can very clearly see that 38 to 150, D is the right answer. 25 is from CRO. He says the screen is displayed a signal and the frequency of the wave is 25 kilohertz. So first, if you're asking time base, first we need to find out the time period. So time period will be equal to 1 over F, which is equal to 1 over 2500. This is 2.5 kilohertz, please. Right, so this is going to come out as 0.4 milliseconds. After, of course, pressing the ENG button and converting this into standard form, your answer should look like 0.4 into 10 to the power minus 3 seconds. So that means that the whole wave with a crest and a trough should be covered in 0.4 milliseconds. Again, the next wave covered in 0.4 milliseconds. If that's the case, then how much time should one box be covering? How much time should be available for one box? So I see that 0.4 milliseconds are being covered in 4 boxes. So the time for one box should be 0.1 milliseconds, right? So the time second should be, or the time settings should be 0.1 millisecond. This seems to be the right answer, or it could have been this answer, but we're dealing with kilohertz, which will convert this into milliseconds. Option A is the right answer. Now, and you can do this manually as well. So this will be 0.1, 0.1, 0.1, 0.1. So 4 boxes make 0.4 milliseconds. This is the right answer. Constant frequency stationary observer. The observer compares the sound arriving. So it is moving towards. So according to the Doppler effect, the frequency should increase and the lambda should decrease in comparison to the original actual sound wave. What is detected by the observer? No change in frequency, that is impossible. No change in wavelength, that is impossible. So a decrease in frequency, no, the frequency is supposed to increase if the object is moving towards you, the source is moving towards you. So wavelength, a decrease, yes, because if the frequency increases, the lambda decreases because the velocity is not changing. So C is the right answer. 27, which cannot be polarized. This is a repeated question again and again. It is only sound wave that can't be polarized. Your electromagnetic spectrum waves are transverse in nature and they can be polarized, right? Okay, please revise Malice's law. I'm surprised he didn't give a question about this one, which is I is equal to I naught cos square of theta, the filtration process. Please revise that. A beam of light of power P has an area of cross section A. The amplitude is X, okay? The beam of the light is then, okay, fine, is increased to 4x and area reduced A by 3. Now I can see that the amplitude or the power of the lens or the power of the laser is increasing and the area is being reduced, which means that it is being focused. The power is definitely going to be much greater than just P. So let's first write down the standard case or the original case. The standard case calls for this idea that the intensity is equal to power divided by area. Intensity is also equal to amplitude squared. In this case, the amplitude is X, right? So let's make an equation. Let's equate both of them. In terms of equation, this is going to become amplitude square is equal to power divided by cross-sectional area R. And that area is given to us as A. So I'm replacing that as A. The amplitude is X, so this whole system replaced with variables becomes X square equals to P divided by A. So P is actually equal to AX square. This is my standard comparison, right? Let's put in the new variables. So the formula is P dash equals to AX square, right? So the new situation is that the amplitude is 4 times and the area is 3 times. So P dash is equal to A by 3 into 4x whole square. This becomes AX square. The variables are being separated and the numbers are being separated. So this becomes 1 by 3 multiplied by 16 because 4 square is 16. So this becomes P dash equals to 16 by 3 into AX square. This becomes 5.3P. So this becomes 5.3 AX square. Since AX square is equal to P, this becomes 5.3P, which is going to be option B, right? Question number 29, 2 sources, setting up a stationary wave. At the center, he says that the 5 maximum amplitudes of the microphone moves and there is distance 2 meters. So what is the 5 maximum? What do they look like? So first, the stationary wave, then this is the antinode, this is the node, then the second maximum, then the third maximum, fourth maximum, and then the fifth maximum, right? Let's number them. So this is 1, this is second maximum, this is third, this is fourth, this is fifth. And of course, we understand that the stationary wave is actually moving like this. The both sources are moving opposite to each other, right? So the distance from this point to this point is actually 2 meters. Now, how to calculate the rest of the things? So this is a quarter of a wavelength, the first part. This is lambda by 4. So we have lambda by 4 plus, this is lambda by 2 plus, again lambda by 2, lambda by 2. So lambda by 2 plus lambda by 2 plus lambda by 4, the last quarter, should be equal to 2 meters. So this is 2 meters. When you add all of them together with the fraction, you realize that this is 2 lambda equals to 2 meters, which means lambda equals to 1 meters. So this is going to be your option D, which is 1 meter. Question number 30, he says, emit and coherent, what must be correct? It is a 100% required condition. He says they are emitted in phase. No, they can be in phase, but always being in phase will not be a condition. They need to have a constant phase difference, not being in phase. The waves are emitted in opposite directions. No, this is a stationary wave setup. He's asking you, or he's tricking you by thinking like that. The waves are emitted with a constant phase difference. Yes, this seems like this is one of the best answers. The waves are emitted with the same amplitude. No, this is not a necessary condition. So C is the best answer. Coherence means constant phase difference, right? Or no phase difference at all. Question number 31, he says a double slit experiment. Okay, fine. Mind you, P does not do anything. P is not even a part of the formula. So the double slit experiment requires AX equals to lambda D, right? Let's replace wherever these variables are. So A was actually the gap width. So this is going to be R. X was the distance on the screen, the fringe separation, right? Which is not mentioned, equals to lambda. D was the distance from the screen. So this is Q. This is Q. So this is what the equation looks like in terms of the variables given to us. He says that student finds the fringes are very close together, which means that X is being affected. X is very small, right? What should decrease in order to increase? So our target is to increase X, right? So X is equal to lambda Q divided by R, right? He says he wants to increase the separation. What can we decrease? Now, very clearly, we can see from this equation, lambda, if increase, will cause an increase. Q increased will cause the X to increase. Only R decreasing will cause an increase because it's an inverse relationship. So distance P does not matter. Q is not my problem. Wavelength is not our problem. And separation R of the slits. Yes, R should be decreased. R should be decreased to increase X, right? Okay, so a very straightforward and quick question. He says, what is the definition? You see, the definition for potential difference, or be that EMF, is actually work done by charge or work done by unit charge. This is W by Q, W by Q. The answer is option A, right? But then what's the difference between potential difference and EMF? If they are exactly the same in terms of formulas, then what's so different about them? You see, EMF actually deals with the fact that how much work done the battery has to do in order to make sure that the electron can travel through the whole circuit. Now, of course, there are going to be some internal resistances of the battery. There are going to be internal resistances of the wires. There are going to be resistance of the resistor itself. So the battery has to compensate for all of them. That is why EMF is a different concept and potential difference is different. Potential difference deals with only how much energy or how much work done is required by the unit charge to move across the component only. That is why they are different. But the formulas are going to be the same. The effort, the work done required by each electron or each packet of electron to pass through a certain point. Passing through the resistor gives me potential difference. Passing through the whole circuit gives me EMF, right? Okay. Question number 33. You can solve this by the longer method, which would be to first solve them in the parallel combination, which would be 1 over 1.2 plus 1 over 4.7 equals to 1 over RT. When you get RT, you will add this with 2.2 to get the final resistance. What you can do is for two resistors, there is a combination, there is a shortcut. The shortcut is product over sum. Product divided by sum. It is exactly going to come from this. After taking LCM, you're going to land at the same answer. So how to take this? So the total resistance of parallel combination comes out as 1.2 multiplied by 4.7 divided by 1.2 plus 4.7. This is what product over sum rule looks like. right? And then simply add this whole answer with 2.2, because this whole combination is going to become, or the formula actually gives us a series combination that if we were to solve this by this method, if we were to solve it by an equivalent resistance, they will be replaced by a single resistor like this one. Now they're both in series. This is the RT value that you calculated from this answer, right? If you add them together in this situation, this is going to give you an answer of 3.2. So I do this directly. So this actual answer is 3.15 kilo ohms. If you do it this way, this is going to be 3.2, up to two significant figures. 34, very straightforward question. He says power is given, voltage is given, what's the resistance? Please be advised, you forget that P is equal to IV, I square R, and V square over R. So we have 25 watts of power. We have the voltage as 4 square divided by resistance. We have this formula, right? So R goes over there, 25 comes down, so this becomes 16 over 25, which is going to be 0.64 ohms. Option B is the answer. Very quick question, time-saving question. 35, he said there is an internal resistance R. We have external resistors. One is fixed, one is variable. He said the resistance of the variable is decreased. If you decrease the resistance of the variable resistor, the whole resistance of the combination decreases, right? Because it is going to go like this: 1 over R plus 1 over the variable resistor is equal to 1 over the total resistance. If you decrease the resistance, the whole resistance of the combination decreases, right? Now, if the combination's resistance decreases, we understand that if the battery experiences lesser resistance, the current through the battery will increase. There will be higher current from the battery. Okay, very simple. So when the current increases, the lost volts inside the battery as V equals to IR, since you have increased the current, the voltage lost inside the battery will also increase. So the lost volts increase, and the terminal potential difference, which is available outside the battery over here, out of the battery, after compensating or balancing out the internal resistance, will now decrease. Why? Because the internal resistance is now taking a bigger chunk of EMF, or the available EMF, and leaving less voltage for you, right? So what's happening to the current? The current is going to increase because overall resistance has decreased. What's going to happen to the voltage V? V happens to be the same voltmeter that is connected at this point, or connected at this point, or is actually connected at this point, because in parallel, the node voltages or the voltages remain the same. So either connected over here or connected over here does not mean anything different. They're exactly the same points. So the voltage decreases because the lost volts are increasing. So the question B would be the best answer. 36 calls for alpha particles and the current and the number of alpha particles as required. So I equals to Q by T. This is 1.5 into 10 raised to the power minus 9. The time is 3 seconds probably. Yes. Multiplied by 3 equals to Q. So Q is also equal to the number of electrons or the number of charges. For alpha particles, we need to realize that alpha particles have 2 positive charges. It goes like this. So they have 2 positive charges, right? So Q, which is equal to 4.5 into 10 raised to the power minus 9, equals to number of the alpha particles into 2 into the elementary charge, which is 1.6 into minus 9t. We understand that be that positive or be that negative charge, the elementary charge, which is 1.6, will not change, is fixed for everyone. The electron or the proton has exactly the same value, except that the charges are different. For electron, this will be negative sign. For a proton, it will have a positive sign, right? So this 2 is added because alpha has 2 positive charges. Now we find the number of electrons comes out as 1.40625, or the number of charges into 10 raised to the power 10. So it's going to be option C. Now please note that if you forget to add this 2, right, you will get the option D as your answer. Now notice how he has tricked you to give you both answers. Only the one who remember that alpha is 2 will get C. 37. The charge carriers in a metal wire are free electrons. Okay, fine. Which statement about the charge carrier free electrons is correct? Okay, let's start reading. Manage the charge increases. No. Electrons, the number of electrons does not increase. When you provide potential difference, when you provide higher voltage, the work done or the energy of each packet increases. The magnitude of the charge is 0 unless it is no. Charges are always there Electrons are always inside a conductor. They are always moving. They are under the drift velocity. They're always moving. And when you apply the potential difference, they move with drift velocity. The sign of magnitude does not depend on the potential difference across wire. This looks like a plausible answer. The sign of charge depends on the potential. No, it does not. It does not. So it's going to be option C. 38. He says, which one has 2 by 3? So charm is plus 2 by 3. Strange is minus 1 by 3e. Top is plus 2 by 3e. Bottom is minus 1 by 3e. So which ones represent plus 2 by 3e? So charm does and top does. The other two don't. So option A be the correct answer. It's from memory. Question number 39. An unstable nucleus decays by alpha or beta negative, becomes a nucleus, then decays again by alpha or beta. He's always mentioning or, which means he's not sure about it and wants us to find out. The process continues until the isotope of the original is formed. Okay, so what we started with, we should get at the end of the process. How could we do this in minimum number of steps, minimum possible number of steps, right? So I believe we remember that alpha is 4, 2 and beta is 0, minus 1, beta negative, right? And we remember from memory, we understand that if there is a beta decay for the proton number actually increases by 1, right? So first, let's emit alpha to reduce this number by 2, then emit 2 betas to increase the number by 2 again, and see whether we get the same answer. So let's start with the hypothetical example. Let's start with sodium. Sodium is 2311. No need to memorize this. You could have started with a hypothetical AZ situation as well. It would give you the same answer. So when you emit alpha particle from this, we are left with some X element where over the top this is 19 and below this should be 9. Right? Now, if now you emit 2 betas, we are emitting 2 betas because I want to add the 2 again into this equation because we want to go back to the original isotope, right? So in this situation, something Y may be formed, but the upper value will not be changed because this is 0, minus 1. In the lower position of the proton number, this will become 10. We emit another beta particle to make something, let's say P. The upper number is not affected, but the lower number, again, because of the beta minus 1, gets added together. So now, whatever we started with, we're getting the same answer. And of course, it's an isotope because the number of protons are different. Protons and neutrons are different, but the number of protons are exactly the same. So the minimum number of emissions required would be 1 alpha and 2 betas. So 1 alpha and 2 beta were required to do the job. So 3 emissions or 3 particles were required. So this is going to be option B. Question number 40 is a repeated question, multiple times repeated question. He says this decays to become boron by some beta decay, but we don't know is it beta positive or beta negative. Let's make the equation. So carbon 10 with 6 decaying to become a boron with 10 power 5. So I suspect this is going to be beta positive because if it was beta negative, this would become 7. This would be 1 more. All right. So what is the mechanism? What is the mechanism? So a proton inside the nucleus of carbon decays to become a neutron and releases a positron, which is 0 plus 1. This stays inside the nucleus and this is emitted out of the nucleus. Now, in terms of quark composition, we understand that proton is up, up and down, and neutron is up, down, down. Now, we understand that, let's find out the common answers. So a proton changes to a neutron. Yes, proton to neutron. So C and D are incorrect. And over here we can see up remains up, down remains down, but 1 up changes to a down. This is the point to note. So 1 up changes down, or 1 up becomes a down. So this is going to be option B. Right? Okay.